So I'm going to do a quick video here about naming the molecular compounds. We've already done the ionic stuff, and now we'll get into when we are talking about a compound made up of two non-metals. Very important that they're both non-metals here. The other thing is that if you have something, for instance, like ammonium chloride would be NH4Cl. All of those are non-metals. However, because you recognize this as a polyatomic ion, ammonium, you know that that would be an ionic compound instead of a molecular or covalent compound. So here are some examples. Carbon and oxygen together, sulfur and oxygen, nitrogen and oxygen. It's both nonmetals together. So to do this, you use prefixes in front of each element name to tell how many there are. So here's your list of all prefixes. Mono is one, of course. Most of them you have seen before. There are a couple rules that go along with this. First of all, the most metallic nonmetal is written first. So in other words, the one that's furthest to the left, or potentially furthest down into the left, that one is going to be written first. So for instance, in carbon dioxide, carbon's first because it's further to the left of oxygen. It is more metallic. Obviously, that would mean the most non-metallic would go second. So it's nitrogen dioxide, not dioxygen mononitride. You put the nitrogen first. All binary molecular compounds end in IDE. So with the ionic compounds, it ended in IDE if you had like an element by itself as the anion. Now, no matter what, it's always going to end in IDE. You have to use the prefixes to tell the number of each kind of atom. So right here, you have 2 sulfurs, 5 chlorines, so it's disulfur pentachloride. The IDE only goes on the second one, disulfur pentachloride. Omit the mono if there is only one of the first element. So in carbon monoxide, it's not monocarbon monoxide, it's carbon monoxide because there is only one of the first element. Oops, hold on. Sorry about that. So writing the formulas, all you have to do is look at the prefixes to know how many of each element there are. As long as you use the proper symbol and you get your numbers right, this is the easiest kind of writing molecules. So in this case, you have 2 nitrogens, 5 oxygens. That would be dinitrogen pentoxide. Now the other thing you have to remember, this is what I was looking for, thought it was on that last slide. If the second element starts with a vowel, a lot of times you will omit the ending vowel on the prefix. So instead of pentaoxide, it's pentoxide. If you had 1 oxygen instead of monooxide, it's monoxide. That doesn't happen with the di and tris. It's still dioxide. It's not doxide. It's dioxide and trioxide. But for the most part, you're going to omit the ending vowel. So sulfur trioxide means you have 3 oxygens, 1 sulfur because there's no prefix on it. So you get SO3. On this one, it's 1 carbon, 14, sorry, not 14, 4 chlorines. So 1 carbon just means it's going to be carbon. And then you have 4 chlorines, so tetrachloride. So here's some examples. If you want to run through them in your head, you can pause the video and do that. I'll get through all of these real fast. And then here are some other examples if you want to practice them. And if you do practice them and want to know if your answers are right, why don't I just go back here in a second. So that would be dinitrogen monoxide, nitrogen dioxide, nitrogen tetroxide, nitrogen monoxide, dichlorine heptoxide, carbon tetrabromide, carbon dioxide, sulfur dioxide, sulfur triiodide. Once again, it's not triodide, it's triiodide. Sulfur hexafluoride, carbon tetrachloride, phosphorus trichloride, carbon monoxide, and dinitrogen pentoxide. The formulas would have 2 phosphoruses and 5 oxygens. This would be ClO, S3F6, Ni3, CCl4, P5F3, S4F6. So hopefully that helps you out. Some things you need to know the common names. Obviously, if you see this, it's not dihydrogen monoxide, it's water. This is ammonia. We talked about that in class. And we will stop there, and I'll talk about acids in another video.